This project is an interactive web-based sketching application built with HTML, CSS, and JavaScript. Its primary purpose is to allow users to upload an image, analyze it pixel by pixel, and generate artistic sketches dynamically using a set of customizable drawing parameters. It integrates several web development concepts, including DOM manipulation, event handling, canvas graphics, and responsive UI design. From a teaching perspective, it provides an excellent example of combining front-end technologies to create an interactive creative tool while emphasizing both user experience and technical programming concepts. The foundation of the project is HTML, which structures the application into multiple interactive sections. The canvas element is central, occupying the full height of the viewport. This ensures that the drawing area is maximized, giving users a clear and expansive visual workspace. The off-canvas panel contains all the controls, including sliders, checkboxes, and buttons, which allows the main interface to remain uncluttered. This design decision is crucial for usability. The user can focus entirely on the canvas without distractions while still having access to the tools when needed. The off-canvas panel demonstrates a common design pattern in modern web development where interface elements slide in and out dynamically to save screen real estate, showing how CSS transitions can create smooth animations and visual feedback for users. CSS plays multiple roles in the project. It establishes the layout, visual styling, and responsive behavior. By using Flexbox, the canvas container is centered both horizontally and vertically, ensuring consistent alignment across different screen sizes. The canvas itself is set to full viewport height, and its width adjusts automatically to preserve the aspect ratio of images or drawings. This highlights an important concept in responsive web design: maintaining proportionality while adapting to various screen sizes. Additionally, CSS handles the appearance and positioning of the off-canvas panel, toggle button, sliders, and checkboxes. Styling choices, such as hover effects for buttons, padding, margins, and borders, enhance usability and accessibility, providing visual cues that improve the overall user experience. Students can learn from this project how to combine layout techniques, positioning, and interactive styling in a cohesive manner. JavaScript is the engine behind the interactivity and artistic functionality. It starts with handling image uploads. The application listens for changes on the file input, reads the selected file using a file reader, and renders it onto an internal image object. This step introduces students to working with file APIS, asynchronous event handling, and image processing in the browser. Once the image is loaded, the drawing logic uses the HTML Canvas API to manipulate pixel data and render strokes dynamically. Each pixel's color is analyzed, and brush strokes are drawn based on customizable parameters such as angle, length, curvature, thickness, and transparency. This demonstrates how the Canvas API allows both fine-grained control over graphics and efficient rendering techniques. The drawing algorithm operates in a stepwise scanning approach. It moves across the image horizontally and vertically according to step sizes, which are influenced by both user input and randomization parameters. This introduces students to concepts of procedural generation and dynamic control of drawing flows. For example, randomization of brush size, alpha transparency, and stroke angle introduces variation, creating more organic, artistic results. It also illustrates how randomness can be harnessed programmatically to enhance creativity. The careful consideration of X and Y step adjustments based on brush size ensures that strokes do not overlap excessively or leave gaps, a practical lesson in combining geometry, user input, and dynamic calculations in graphics programming. Event handling is another critical aspect of the project. Users can start and pause the drawing process, clear the canvas, or download the final sketch. Each action is tied to DOM events, demonstrating how JavaScript interacts with the browser to modify both the state and presentation dynamically. The pause resume functionality exemplifies state management in an interactive application, while the download feature teaches how to export Canvas content as a standard image format, bridging the gap between live graphics rendering and persistent media output. By exploring these functionalities, students gain insight into user-centric programming and integrating interactivity seamlessly into a web application. The project also introduces important concepts in performance optimization. Drawing on the canvas is computationally expensive, especially when scanning pixel by pixel. By leveraging techniques such as request animation frame, the application ensures smooth rendering while keeping the browser responsive. Students can learn about balancing real-time updates, animations, and performance constraints, a valuable lesson in practical web graphics programming. From an educational standpoint, there are multiple opportunities for extension and enhancement. For instance, additional brush types, such as circular, dotted, or textured strokes, could be implemented to diversify artistic output. Color manipulation techniques, such as applying filters, gradient brushes, or color palettes, could deepen understanding of pixel data processing. Adaptive algorithms could be added to automatically adjust brush density based on image brightness or contrast, introducing students to image analysis and algorithmic art. Furthermore, adding touch or pen input support would expand usability on tablets and touchscreens, providing a lesson in device-specific input handling. Integrating saving and loading of sketches with local storage or server-side databases could demonstrate state persistence and full-stack considerations. Finally, enhancing the UI with real-time previews, live sliders, or layer management introduces concepts from professional creative software into a web context, bridging theory and real-world application. Overall, this project combines fundamental and advanced web technologies in a coherent, interactive, and visually engaging application. Students learn how HTML structures content, CSS manages layout and style, and JavaScript drives dynamic, pixel-level rendering with interactive controls. It highlights the importance of user experience design, responsive layout, performance optimization, randomness for creative effects, and stateful programming. By dissecting and extending this project, learners can gain hands-on experience in multiple areas of front-end development, from UI, UX design to graphics programming, making it a rich and highly educational example of modern web development in practice.